Hi, my name is Tucker Bialis, and for this presentation, I'm going to explain to you my final project, which was on the Koenigsegg Regera, which I consider the fastest and most advanced hybrid quote-unquote vehicle in the world. What is it? It is the latest mega, hyper, super, duper, whatever car from the Swedish manufacturer Koenigsegg, and is driven by both gasoline and electricity. First, it is the first of its kind with Koenigsegg Direct Drive, which was designed by owner Christian von Koenigsegg himself. Regera means to reign in Swedish, and only 80 of these vehicles will be made. The purpose of this car was not just to be a race car, as in Koenigsegg's other models such as the 1.1 and the Regera, but this car has luxury and daily drivability in mind as well when engineered. The interior is fully equipped, has 6-way seats, navigation, infotainment, supreme sound, soft touch materials, and 3G phone integration, as well as Wi-Fi capability, and has fully hydraulic doors, chassis control, and body, all of which add very minimal weight. Specifications for the Regera are that it has a 5.0 liter twin turbo all aluminum double overhead cam V8 engine. It's pumping 20 pounds of boost and makes 1,100 horsepower and 944 pound-foot of maximum torque. Combine that with the 3 electric motors that are in its drivetrain, which come to 700 horsepower and 644 pound-feet of torque. The car weighs 1420 kilograms dry and 1628 kilograms wet with all fluids and full tank of gas, or 3,589 pounds, which isn't much more than specific race cars. The battery inside the vehicle is a 9.27 kilowatt hour 620 volt battery. It is flooded and liquid cooled and weighs 253 pounds. It is the most energy dense battery ever in a road car. It is also a partially plug-in vehicle. It uses a Type 2 Mode 3 charger, and the body is a carbon fiber monocoque with a aluminum honeycomb support structure around the battery and other key components in the vehicle. So the truth about the car, it is considered the fastest accelerating production car in the world, and that's not its 0 to 62 miles per hour time, which is 2.8 seconds, or its max miles per hour, but it's the overall acceleration. The car goes 93 to 155 miles per hour in 3.2 seconds, 0 to 190 miles per hour in 12.3 seconds, and to top it all off, 0 to 248.5 miles per hour in less than 20 seconds, which is the real jaw dropper. It can go pure electric operation up to 22 miles, which is more than comparable vehicles, and has as low as 32 grams of CO2 emissions per kilometer. So the special part about this vehicle is the Koenigsegg Direct Drive system. This is the first of its kind. Koenigsegg doesn't like to call the car a hybrid, which is why he coined the term KDD. He thinks hybrid means compromise, and where compromise is made, this is his solution to the problem. This driveline has no gearing losses, as in it has no transmission and no reverse gear. This makes for less loss and conversion of power, and Koenigsegg claims a 50% reduction of drivetrain losses over conventional hybrids at highway speeds. This system uses the battery, which is in line with an electric motor at the front of the crank, which is a 160 kilowatt motor. This motor at the front is used for torque supplementation as well as starting the engine. The engine is in line with it right here, and then that goes to the hydraulic coupling, which goes to a final drive ratio, and 2 other 180 kilowatt electric motors on either side of the final drive ratio, which is 2.85 ratio. These motors are supplied by YASA, which is the leader in torque density motors. The electric motors do everything from supplement low end torque, fill power curve. It does generate power for the vehicle as well. It uses torque vectoring. It is used for reverse, um, and it also starts the motor, supplements extreme driver inputs, and many more. Uh, the the hydraulic coupling works kind of like a torque converter. It slips very little, however, and locks at 30 to 40 miles per hour, so the vehicle uses only electric propulsion underneath that speed. And the engine has one speed and revs in correlation all the way up to its red line with car speed. This system only adds 195 pounds over a conventional internal combustion engine and a 7-speed DCT transmission. The Yasa electric motors, they're used by the Regera, and it stands for yokeless and segmented armature technology. They are axial flux motors slash generators with a pancake style rotor and stator. This design is compact and is extremely useful in weight savings and in space savings. The implications of this direct drive technology could be useful for future hybrid vehicles. There's less components, less drivetrain losses, and this could equate to a gain in fuel efficiency. The design is also lightweight. However, something similar has been done with the Honda Accord hybrids that have recently come out where they have no gears, but it's not in this performance matter. You can't get quite as much power out of their system. The technology could trickle down into economy vehicles. It could save manufacturers on costs with less components, as well as consumers can save with less gas expense. And those are my graphic sources. Thank you.